Hi, I'm David McQuillan, Senior Specialist on ATG's Reality Capture team. Take a look at our footage from our recent Reality Capture demo day, or take us through how to set up a crosshatch survey using SiteScan, a DJI drone flight planning software.
What we have here is SiteScan. If anybody uses drones for mapping, or specifically DJI drones for mapping, this is kind of a third-party flight planning software or data collection software. So I'll just kind of quickly go through a couple of different flight plans here. So first thing I would do is, assign which drone I'm using. So once that's selected, first I'm going to show you a crosshatch survey. So in this case, a crosshatch survey would be used, for either you could use it for vertical structures as long as they're you know, the height of them is relatively low. If you're using something much taller, like, for example, the building we're in, the 11, 12-story building, there's a different flight plan for that, and I'm going to show that as well. But for right now, I'm just going to go ahead and work through this. So let's just give it a name, test, give it a location we can. You notice there are ArcGIS layers. I don't know if anybody out there are Esri ArcMap users or ArcGIS users, but because this is actually an Esri product, you can actually import, if you have an ArcGIS Online account, you can actually import other layers into this. So I'm going to go and click Next. And basically it's just gonna pop up a polygon, and within those polygon we're gonna have our flight lines. And because this is a crosshatch, we're gonna be going, both directions, right? North to south, east to west. And then for any sort of drone flight planning, there's a couple important considerations. The first being the altitude, so basically how high we're going to fly, and that's called ground sampling distance. And so if you see there at the bottom, sort of in the middle, it's 0.7 inch per pixel resolution. That's our ground sampling distance. So at 200 feet altitude, that's basically the amount of detail we'll be getting. We're going to skip over gimbal angle and hatch angle because that's going to be something sort of more automatic done with the drone. And then we're going to just hop into advanced, and we're going to go into overlap. So the other most important thing with drone data collection and basically the settings that are going to figure out how much detail and the quality of your data and things like that is also the overlap. So with this crosshatch going in both directions, we're going to have a lot of overlap, right? So maybe if we're just doing a traditional area survey where we're only flying one direction, we may want to bump up this side lap to 70 or 75%, right? So the first one is called overlap. That's what I would call maybe front lap. So as the drone is flying forward, how often is it going to take a photo as it moves forward? Side lap is when it goes to its next flight line, how close is that next flight line, right? Return altitude, that's a safety altitude. So basically, when it's done, what altitude is it going to fly back to its home position and then move down, right? So just real quick, so this is it would be a 4-minute flight, as you can see there in the bottom, 0.7 inch per pixel. It's going to be about 2.5 acres, take 36 images, and it's all going to be done within one battery. So it's a really nice, flight planning. Right now I'm obviously not connected to a drone. I'm in an office, but I can save this and then use it again later. So even if you're just sort of maybe quoting a job or just trying to figure out how much time or batteries or logistics it's going to take, it's a great planning tool as well.